One definition of congruent is when two figures have the same shape and size. But another is when you have a preimage mapped exactly onto an image. So when we're doing transformations, if you can map one figure directly onto another figure through a series of transformations, then those two figures are congruent. Correspondence is when a pairing of each vertex and side form one figure onto a congruent figure. So when we have two congruent figures, the corresponding sides and angles are the ones that match in between them. Like this side of this triangle matches this side of the congruent triangle. So in the figure below, the triangle on the left has been mapped to the one on the right by a rotation of 240 degrees about point P. And we're identifying all 6 pairs of corresponding parts, 3 corresponding angles, 3 corresponding sides. So angle A has been rotated around to here and has become angle X. Angle B has been rotated around to here and has become angle Y. And angle C has been rotated around to here and is now angle Z. And because angles A and B correspond to angles X and Y, side AB corresponds to side XY. But we could also look at how side AB has been rotated around and see that it matches XY. Side AC corresponds to side XZ, and side BC corresponds to side YZ. Now that we see that all 3 angles correspond and all 3 sides correspond, is triangle ABC congruent to triangle XYZ? Yes. They are congruent, and this is the symbol for congruent, an equal sign with this like squiggly line above it, because triangle ABC maps onto triangle XYZ by a rigid transformation. And in this case, that rigid transformation was a rotation. What rigid motion mapped ABC onto XYZ? We know that up here. It was a rotation of 240 degrees about point P. ABCD is a square, and segment AC is one diagonal of the square. Triangle ABC is a reflection of triangle, this says ABD, which is incorrect. It should say triangle ADC, right here, ADC. So go ahead and correct that. Across the segment AC. So if I reflected this triangle across this line, in other words, just flipped it over, folded it over, whatever you want to say, then it should be exactly the same triangle on the other side. So complete the table below, identifying the corresponding angles and sides. So what angle corresponds to BAC? DAC, because if we fold this over, this is the angle that would turn into this angle. So angle DAC. What about angle ABC? Of course, this one would fold over into angle ADC. And angle BCA would fold over to angle DCA. Now, what about the sides? Side AB would fold here and become side AD. Side BC would fold over onto side DC. And side AC would be reflected onto itself. It would be the same side in both triangles. So, are the corresponding sides and angles congruent? Yes. The triangle is a rigid transformation. Remember, again, rigid transformations preserve the same size and shape as the original. And is triangle ABC congruent to triangle ADC? Yes. Triangle ADC is a reflection of triangle ABC. And remember, a reflection is a rigid transformation. Okay, go ahead and pull out the next piece of paper. So we've covered all four kinds of transformation at this point, and there's just one last kind of transformation that we need to talk about, which is a composition of transformations. A composition of transformations happens when two or more transformations are combined to form a single transformation. So it's when we have multiple transformations, and this could be two of the same kind of transformation, like two translations, or it could be a rotation and dilation, or any other combination of transformations. But a particular one that we want to highlight here is the glide reflection, which is a translation followed by a reflection. So it moves like gliding, and then it reflects. So in our notation, you can see that the symbol for compositions is an open circle, and we have a reflection across the x-axis mentioned here, and a translation +3 on the x, followed by +4 on the y. But you should note that when we have it written this way, it actually goes from right to left, and the reflection will follow the translation. So the translation happens first, because it's closest to whatever figure that we're talking about here, and then it goes backwards to the reflection across the x-axis. So first we translate, then we reflect. Okay, let's look at an example here. The vertices of triangle PQR are given here. Find the image of triangle PQR after a glide reflection, reflection across the x-axis, and a translation +4 on the x, 0 on the y. So we start by listing our original points, P, Q, R. So P is at 2, 6. Q is 4, -2. R is -3, -3. So our first transformation is a translation +4 on the x and 0 on the y. So I'm just going to add 4 to my x coordinates, and my y coordinates are going to stay the same. So P prime is going to be 2 + 4, 6, and then 6 is still 6. Q prime is going to be 4 + 4 is 8, and then -2 + 0 is still -2. And R prime is going to be -3 + 4 is 1, and -3 + 0 is still -3, so it stays the same. Next, we're going to have a reflection across the x-axis for our final piece of this transformation, this composition. And remember, when we reflect across the x-axis, the sign on the y-coordinate changes, and the x stays exactly the same. So P double prime is going to be at 6, -6. X stays the same, sign on the y changes. Q double prime is going to be 8, x stays the same, -2 becomes +2. And R double prime will be at 1, +3. The endpoints Mn are located at these coordinates. Find the image of Mn after the transformation of a R180 composed with RY, let's just say y-axis. And this has the reverse of the composition of the notation we've been using. Let's fix this really quickly. Reflections, remember, should be a capital R, and then rotations should be a lowercase r. And here we have another reflection, capital R. So this is a rotation 180 degrees composed with a reflection across the y-axis. So first, point M is located at -2, 1, and then point N is located at 3, 4. Our first transformation is the reflection across the y-axis, because remember we go from right to left. And if I am reflecting across the y-axis, I'm going to move this way or this way, and so the x coordinate is going to change signs and the y coordinate will stay the same. So m prime is going to be at positive 2, 1, and n prime is going to be at negative 3, 4. Then if we do a 180-degree rotation, remember we just flipped the signs on both x and y for a rotation 180 degrees. So m double prime will be at negative 2, negative 1, and n double prime will be at 3, negative 4. Now here we have a series of transformations that have already been done, and they want us to describe what transformations happened. So each one of these is a composition of transformations that carried a pre-image onto an image that is a double prime, so two transformations happened. This first one was a translation over to here. It shifted it this way, followed by a reflection across the x-axis. So it was a translate and then reflect, or a glide reflection. This one was rotated and then translated. So it was turned to the side and then it moved. So rotate, translate. And it was rotated either 90 degrees counterclockwise or 270 degrees clockwise before they moved it. Okay, here they want us to give a single transformation that will map ABC onto A double prime, B double prime, C double prime. So get this onto this. Notice that what's happened here is that it's been flipped this way and then flipped again, or I guess rotated actually. Yeah, rotated. But what we could do, these are mirror images of each other, and we haven't talked about this kind of transformation, and we won't be doing too much with it, but if you drew a line, because you don't have to reflect just across the x-axis or the y-axis, although that's what we've been doing, you could have the line y equals negative x here, and you could reflect across that line. You can draw a line anywhere and just flip a figure across it, and that would be a reflection across a specific kind of line. So in this case, we could have a reflection over the line y equals negative x. And then finally, to get from here to here, it looks like reflected it over here and then reflected it over there. But we could get from here to here just by reflecting over the x-axis. So reflection over x-axis.